Okay, here we are with this second video for the implementation of the robot class. In the previous video, we looked at part A, the forward move blocked. We also did the haul is clear method, which we're not responsible for implementing, but we want to test it, so we coded that. And we made a constructor to initialize these variables, these instance variables. And now, in this video, I want to take a few minutes to code the move method, which is part B, and then the clear haul method, which is part C. Now, this is how the move method works. Excuse me. The move method first checks to see if there's any items in the current tile. So basically, I would think something like checking if the items in the tile is more than 0. And if there are items in the tile, you only remove one item, just one. So I'm thinking something like if haul of I is greater than 0, then haul of I minus minus, subtract 1. After it removes a tile, if there are any more items in the current tile, then nothing else happens. The robot remains in the same tile, so you don't move anywhere, and it remains facing in the same direction. But if you remove an item, and then as a result of removing that item, there are no more items in the current tile, so there's 0 items. So something like if haul of I equals 0, then the robot needs to move forward one tile. And so if the robot is facing to the right, like it would be right here, for example, right here in this example, you would remove that one item. It would result in 0, and it's facing to the right, so it would move one tile to the right, and that would be it. Or if the robot is here, for example, let me check. Where am I? Right here. You remove the tile right here, and the robot cannot move to the right, so what it does is it just turns in the opposite direction to face left, but it remains in this tile. So that would happen if there's a wall. And then finally, if you remove a tile, and I think there's no example here, you would, and there's 0, if you remove an item and there's 0 items remaining, you keep moving to the left. So basically, there's a few things we need to check after we remove an item from the tile. There's a few conditions we need to check here. These 3 mainly. Or this 3, I mean, but move if you can move to the right, or move if you can move to the left. And if you cannot move to the right, then turn to face the opposite direction. And if you can't move to the left, then turn to face the opposite direction. So let's code the move method. It's actually a pretty straightforward method. I understand that when we're coding the move method, we're only moving once, and that's it. Maximum, just once. We only remove one item, and that's it. So we remove one item, check to see if there are no more items in the tile, and if there are no more items in the tile, move one block to the right if you can. And if you can't move to the right, then just turn to the left and stay in place. Just as a heads up, the clear haul method, this is where it's basically clear haul is gonna execute the move method repeatedly. So this is gonna take charge and actually clear the entire hallway. And so I guess what I'm trying to say is that we don't need a loop in the move method. So let's go here to our robot tester class. We'll come back to this, but we are once again, we can only from outside of the robot class, we can only test methods that are public. The only method that is public is a clear haul method. And so right here I have the clear haul method. It is the only public method. The move method is a private method. The haul is clear is a private method. And so on and so forth. So move. Let's start with move here. Again, we can access haul, which is an array of integers, because it is declared outside of any of the methods. Notice how its declaration, which is line 3, is within the robot class, but it's not in any of the methods. And so these instance variables, the reason why we declare them out here is because we might want to use this variable, which is an array. We might want to use it or access its elements from within more than one method, multiple methods. And you can see that's true because right here we accessed an element from haul, and we're going to do so again in the move method. And so I'm going to say if haul of, now I'm not going to put I here because I would have to then initialize I up here. I would have to say I int I equals 0. But that's not what I want. There's a variable that tells me where the robot is at, and that's the position variable, pos, right? So if haul of position, or pos, is greater than 0, which means that, let's suppose that pos is set to 3. If haul of 3 is more than 0, or I guess, let me actually go with the example that they have here. The robot starts at position 1. Okay, so 1. Position is 1. Up here, the index value, not the elements, not the value of the elements, but the actual index value. If haul of 1 is greater than 0, which it is, look, it's right there, it's 1. Then we want to subtract 1 from haul of position. So what I'm going to do here, if this is true, I'm going to say haul of position. So the element at location 1 of position is 1. Minus minus, that subtracts 1. That's all it does. So I want to do that. I want to verify that if there's an item at that position, I want to remove just one item. So this only removes one item. We're not in a loop. Now after that check, I then want to check to see if after removing that item, the element at that same location, haul of position, is equal to 0. And so that would be the case when the element at this location is 1. 1 is greater than 0. Okay, and then so let's subtract that. Let's subtract 1 from that that location. And so now 1 minus 1 is 0. And so now we would be here. Now there's more than one thing that I want to do in this if statement, so I need some curly braces. If there are 0 items at this position now, I want to move to the right. So I need to check a few things. Now, how do you move to the right? Well, what you're going to do is you're going to increment pos. Pos is the index value. And so it is initialized to 1, at least for this example, it's 1. And after you remove that item, you want pos to be 2 if you're facing right. So I'm going to say, okay, so if we have 0 items, that's what this checks. If we have 0 items in the current tile, I'm going to say if I'm facing right, and because I need to check whether I can move to the right, and that's what this does, right? This method returns true if I'm facing right and the position is the last tile on the hallway. I'm going to return true. So if this method returns true, that means I cannot move to the right. If I'm facing right and my position is the end of the hallway, I cannot move right, so it returns true. If I'm not facing right, which means I'm facing left, and my position is the beginning of the hallway, I'm also going to return true, which means that I cannot move left anymore. Otherwise, I'm going to return false. And so I'm going to say if I'm facing right and my forward movement is not blocked by a wall, which would be if not forward move blocked, understand that I'm executing the code, doing this right here, executes all the code in this method, which is this method right here. So I'm executing all this code. If I'm facing right and I'm not blocked from moving further to the right, I want to increment position by 1. So pos plus plus. However, if I am facing right and I'm not, and my forward movement is blocked, I want to face left. And so I'm going to put here else facing right equals false. Now, it is true that I'm either going to be facing right. Actually, no, there's more to this than that. Because I'm thinking here that I was thinking of doing the following. Let me write it down and explain it. If to check the left boundary, I would say if I'm not facing right, and I would once again do this, and my forward movement is not blocked. So once again, the exclamation marks means not, and this returns true if I cannot move forward anymore. So if I get false, basically, if my forward movement is not blocked and I'm facing to the left, I would say something like position minus minus to decrement or decrease the index value. Now, I already see a problem here, and the problem is that let's say that I'm facing right and I cannot move forward. So I would not increment my position. I would set facing right to false, and then I would carry out this statement, which then this is true because I am facing right. Well, I'm not facing right, I guess. And then the exclamation mark would negate that false statement, which would then make the whole thing true and not move forward. So what I'm thinking is that I need to do an else if. Else if I'm facing right and my forward movement is blocked, then just face left. Else if I'm not facing right, which means I'm facing left, and my forward movement is not blocked, then decrease my position by 1. And then finally, I'll do the last else if. If I'm not facing right and my forward movement is blocked, I want to face right, which I would do by just setting this to true. Notice the 1 equal sign here means that I'm assigning a value to facing right. I'm saying facing right equals false. I'm not checking for equality. I'm not checking to see if facing right is equal to false. I'm saying store false in this variable. I believe that does it. There's only one way to find out, and that's to test. Now, to test, again, the only way I can test this is by executing this move method. Execute all the code in the move method, and I do that by putting that. So in the clear hall, move. Now with these values, which are the values that are given in the example, 1 item, 2 items, 2 items, the robot starts at position 1, which is 0, 1, 2, 3. It would be this location. If I execute clear hall and I'm facing right, true means that I'm setting a true to facing right. I execute this method, it's gonna execute all the code in the clear hall method, which is gonna execute the method move, and this calling the move method executes all the code in here. And I would expect, from the current scenario, I would expect this to be the 0 and then my robot to move to the right. Now, how do I check to see if those things happened? Well, let's do this because I want to test it, right? I want to test to see if this is working fine. I'm going to do the following. After I move, I'm going to print. I'm going to print the position of the robot because it should have moved. This print statement is temporary, by the way, okay? I'm going to get rid of it eventually. Position, and I'm going to print the position variable. I want to know the position of the robot. I also want to know whether the robot is still facing right as it should. So I'm going to put here facing right. And I'm going to put here facing right. And then I want to print all the elements in hall, and it's a quick. So hall is a one-dimensional array. I'll use a for each loop. It's quick and very easy to program. For each integer x in hall, system.out.print. Actually, I'm going to print them in the same line, so I'm not going to include the ln, and I would do maybe x, whatever x is, followed by a space so that I can have a space between the elements, like that. Okay, I'm going to compile, and I haven't made any changes to this class, so I'm just going to run it. Perfect. So check this out. I know the robot initially was here. There was 1 item here. I execute the move method once, okay? Because I execute the clear hall method. The clear hall method executes the move method just once, and then I'm printing this afterwards. And that's this right here. So I took away 1 item. The robot is now in position 2, which would be 0, 1, 2. So it's here, and it's still facing right. Now let's try this, okay? Why don't we put this inside a loop, which is not exactly what we want to do, but we're actually practically almost there. Let's put this in a loop so that we can carry out this multiple times, so we can see it in real time. So I'm going to put it here while. Now we already know how many tries it would take. It would take 9 tries. That's what it says after 9 moves. So let's say while I want to loop 9 times. So if I start my counter, a variable that's keeping count at 0, then I would say while count is less than 9, and why less than 9? Because this would be 0, and then if I count from 0 all the way up to 8, that's 9 iterations. And so the last value that is going to be that where this condition is still going to be true, count less than 9 is going to be when a count is 8, which corresponds to 9 iterations. And so I'm going to put this inside the loop. Click tab, it automatically indents for you. And I want to increase count, otherwise I'm going to be in an infinite loop. So after I do all this, I want to increase count by 1. And compile. And let me run and see what happens. Okay. Okay, this is what happens the first time. I take 1 away. Oh, I take 1 away, right, from this location. So now it's 0, and I move to the right so that I'm now at position 2. I'm still facing right. This is my new hallway. After that, I take 1 away from here. So now this is 1. My position, where's this? Did I highlight? Oh, it's because it's printing it on the same line. I need to. I was getting a little confused here. After I print the entire array, this prints the array. I want to print a new line so that the next thing that I print is on the next line. And I'm actually also going to put some symbols to make it easier to identify. So some stars maybe. Oh, they need to be within double quotes. A string of stars. Asterisks. Let me compile and let me run it one more time. Okay, let's see. This is a little easier to see. Okay, I started here. There was one element. I took that element away, moved to the right. So now I'm at location 2 and I'm still facing right. Now that I'm here, I'm going to take 1 away and I'm not going to move this way because there's going to be 1 item there still, and I'm still going to be facing right. So that's this right here. I'm still at this location. I've removed 1 and I'm still facing right. I'm going to remove this item from this location, from location 2. That's going to result in 0, and so I should move on to location 3. That happens right there. Good. I remove an item here. I'm going to have 1 item left, so I'm going to stay at that same position, and I'm still going to be facing right. Good. I'm going to remove an item here. I'm going to have 0 elements, and I'm going to try to move to the right, but I can't. So instead, I'm going to turn to the left and stay at this location. And you see how still same position 3, but now I'm not facing to the right. It's false, and I've removed the item. Right here, because there's no item to remove, I just simply move. When I execute the move method, I move to the left to position 2. I'm still facing left. Again, I'm right here. There's no item to remove, so I move to the left. So I'm at position 1 now, and I'm still facing to the left. And then finally, I'm right here. So I move 1 unit to the left. So I'm at position 0. I'm still facing to the left. There's 1 item there. And then finally, I remove that item. So that would be 0 items there. I try to move to the left, but I can't. So I turn to the right. So there it is. And I remain at that location. Perfect. Now, there's just one last thing that we need to do here. So we actually have practically coded clear hall without, I guess, intending to, or maybe we wanted to do this, but without intending to, we executed this method, or we implemented this method, clear hall. It took care of it. That's what clear hall was supposed to remove all the items from the hallway, and we've done that effectively. What we need to do here is, it took 9 turns to remove the elements from this hallway, but if I was to change this to maybe like a 2 there and maybe a 3 here, these are arbitrary numbers, I would expect to to take more than 9 tries, probably 11 tries, because I've added 2 more items. And so if I change those, if I compile and I run again, I'm going to see that at the very end, so this is my new array, right? I started with 1, 2, 3, and 2. And so I remove an item from here and then move to the right, so on and so forth. If I keep it at 9, there's going to be 1 item left here. And so I would have to come in here and say, okay, make it less than or equal to 10. And let's then say compile, and then let's test it. There's still 1 item left, because I think I was at position, well, this was with 9 tries, I was still at position 1. So I would have to go in here and then change this to 11. So for every item that you add to your original hallway, for every item that I add here, that increases the turns by 1, the amount of turns it would take, the amount of iterations. Now if I compile and then if I run this, I would expect to have an empty hallway at the end, which I do. Now there's 11 iterations here. And we don't want to hard code this because we don't know how many items are going to be in the hallway to begin with. That is up to the user, the person using our program. They are probably going to decide how many items are in the list. And so what's good though is that we have a method that, although we didn't have to implement, we didn't have to worry about how it did what it did, there's a method that returns true if the hallway is clear, if there's no more items in the list. That's what this method does from our previous video. So clear is true if I find an item in my hallway, and I do that by seeing if the hall of I is greater than 0. I set clear to false and I return false. I return clear. When I set clear to false, I never set it back. There's no way it's going to be set back to true. And so right here, I want to keep moving while the hallway has items. And so I'm going to execute all this code in hall is clear. It returns a true or false value. And I'm going to say while hall is not clear. Again, the exclamation mark means not. While the hallway is not clear, keep moving. And I could get rid of this. I could get rid of this. Oh, you know what? We need to return an integer, and the integer is the amount of iterations, the number of turns. Let me just show you right here. A hall is clear hall is in the example at the beginning of this problem, clear hall would take the robot through the moves shown and return 9 because it took 9 turns. And so, as a matter of fact, I can just keep count, the variable count. So I can actually keep it and say count is 0. After I make a move, increase count by 1. And then I'm going to return count. I'm trying to think here if I might have to start this at 1 instead. There's only one way to find out. Let's test it. Now, what I don't need is all this extra stuff. That's just for my benefit to see if it was working as it should be working. I'll leave it here for a minute. I want to print count. So I'm going to compile here. I'm going to go to my robot tester. Clear hall is going to return to me the number of turns it took. So I want to print that. And I'll put here, just to be a little more clear, it took blank turns. This is just for description. You wouldn't have to do this to clear the hallway. So R2D2 is a robot I execute the clear haul method within R2D2. It's going to return to me how many times, how many moves I had to make to clear the hallway. So I'm going to compile because I've done some changes, and I'm going to run. And it says 11 turns. Let me change this back to what it was, 1, 2, and 2. I expect 9. 9 turns. Perfect. So notice how it's printed at the very end, because when you execute this code, the computer, it cedes control to the clear haul method, and in the clear haul method I have all these print statements. So those are printed and printed and printed and printed. Once you're done printing, return count to my tester class. So you come back here and then you print all this. As far as the implementation here, I would just, this I wouldn't need. That's it. This is it for clear haul. And I actually want to make a comment here about using a for each loop. A for each loop in this case would probably be more appropriate, because we use for each loops when we're trying to access elements of an array. Haul is an array. I'm trying to look at every element in the array, and I'm not going to change the value. I'm not going to change the value of any of the elements. Whereas over here, I cannot use, well, I'm not looping anyways, but I would not be able to use a for each loop here because I'm changing the value of the elements within the haul. And so this is just for your information. We could have gone away with saying for every integer x in haul, remember that this data type int has to match the data type of the array haul. So the haul has an array of integers. This denotes that it's an array. And so for each integer x in haul, meaning x is going to be every element in haul, if x is greater than 0, then clear equals false. I'm going to compile this, and I just for the sake of verifying that nothing changed, and notice that we have here the correct answer, and that we don't have this anymore because I deleted the print statements in the clear haul method. They're gone. That does it for this class. Code along, ask me questions if you have any questions.